So always my practice tests are the best thing to study for our tests. Let me just start into this. First four problems give me graphs, want me to find the domain and range. The first graph, I didn't know if the points were showing up well enough because of the color, so I rewrote the points in. This graph has an open circle marked on the left edge, a closed circle marked on the right, and doesn't need to be extended. There won't be any infinities in my domain nor in my range. If one or both of the ends isn't marked with a point, the graph needs to be extended and you'll pick up an infinity. For this graph, the graph starts, its left edge starts at the point -1, -6. That's going to be where my domain starts. I'm going to start the domain at x equal to -1. And then the point over there is my far right edge of the graph. That's where I'm going to end my domain. And domains are x's. So that's going to be at x equal to 4. When I go to write my answer, open circles, points that have open circles get round brackets. So at the start of my domain at x equal -1 is going to be a round bracket. Points that are marked with closed circles, those values get square brackets. So to start my domain, it's -1 round parentheses, comma 4 square parentheses. For the range, I need bottoms and tops, and I need y's. The point that I marked for the start of my domain is also the start of my range. It's the start of the domain because it's the far left point. It's the start of the range because it's the bottom point. And for the ranges, I need y's. For the domains, I need x's. This point is the end of my range because it's at the top of the graph. I read bottom to top for the range, left to right for the domain. X's for the domain, y's for the range. So my range is going to start at -6. Because it comes from an open circle, I'll get a round parentheses. My range is going to end at 3 because it's a closed circle, I'll get a square parentheses. So my range is going to be -6, comma 3, round parentheses and square bracket. I have the same points from this problem for the domain and range of problem 2. They're showing up kind of poorly, but maybe good enough that the graph that I wrote in question 1 isn't cluttering the points or obscuring the points. In question 2, when the points aren't connected, you're not supposed to connect them. To write the domain, you're just going to write the x coordinate of each point. To write the range, you write the y coordinate of each point. I like to do my numbers from smallest to largest, so I'll do that. The x's that I see are -1, +4, and +2. That's the x coordinates of my points. When I write my domain, I could put the numbers in any order when the points aren't connected, but I like putting them in ascending order, so it's going to be -1, 2, and 4. And then the range, when the points are scattered like this, are going to be the y coordinates of my points. The y coordinates are -6, -1, and +3. So my range is just going to have the 3 y values, -6, -1, and +3. And that's all there is to do for that. 2 more domains and ranges, but we need extensions. Problem 3, the left edge doesn't need to be extended, but the right edge does need to be extended. The right edge is going to go up and to the right. When it goes to the right this way, it's going to give me the end of my domain, which is going to be x equal to +infinity. And because it's going up, so the far right edge of the graph is going to be +infinity. That's the x direction. And since it's going up, the end of my range, or the top of my graph, is also going to be at a +infinity. In terms of starting the domain and starting the range, this point that maybe doesn't show up so well, the point negative 4, 3. This is going to be the start of my domain because it's the left edge of the graph. So my domain is going to start at the x coordinate of the point on the left edge of the graph, which is negative 4. It's marked with a closed circle, so I'll get a square bracket. The bottom of the graph is where the start of my range happens. And again, if this point isn't legible, it's the point negative 1, negative 6. And the start of my range is going to be y equal negative 6. So my domain is going to go from negative 4 to positive infinity. And I need to get the right kind of brackets or parentheses. Since the point negative 4 through is marked with a closed circle, I get a square bracket in my domain next to the negative 4. Infinities always get round brackets. For the range of this problem, the range is going to start at negative 6 and end at infinity. The negative 6 point, the point that the negative 6 comes from, is marked with a solid circle, so that's going to get a square bracket, and infinities always get round brackets. The only point that I have marked in problem 4 is the point 2,8, and both edges need to be extended. This edge is going to extend that way, and that's going to extend off to the left, and that's going to make me start my domain at x equal negative infinity. This edge, as it's going down, it's going to the right. That's going to make me end my domain at x equal positive infinity. There isn't a left nor a right edge. Both the left and the right edge are getting wider forever. There isn't a start or an ending point that I can mark. In terms of my range, the start of my range is at the bottom here. Both sides are equivalently the start of my range. They're both going to the bottom of the y-axis. The start of my range is going to be at y equal negative infinity. There is a solid top to this. The top of the graph gives me the end of my range. And the y-coordinate of that point at the top is what I need. It's going to be y equal to 8. So my domains are going to go from negative to positive infinity. And infinities always get round brackets. There's no concerns there. So the domain is all real numbers or negative to positive infinity. The range is going to be negative infinity to 8. The infinities always get a round bracket, whether they're positive or negative infinity. And here, the 8 that ends the range is going to get a square bracket because that's marked with a closed circle. So there's a lot of problems on this test that don't require algebra, which means they're hard to give partial credit for. So just make sure you know how to do all the problems. The next 3 problems give me functions and ask me to find the domain without having a graph. In problem 5, it gives me a fraction. To find the domain of a fraction, you ignore the numerator. If you set the numerator equal to 0 when you're trying to find the domain, you'll get an x-intercept, which has nothing to do with a break in the graph of a fraction. The algebra that I'm going to need to find the domain of a fraction is to set the denominator equal to 0. It's better if the denominator doesn't have a square, but it's not ridiculous if it has a square. Because the denominator has a square, when I set it equal to 0, I need to factor. And this is easy factoring. Split the x squareds evenly as a couple of x's to start my parentheses. The numbers at the end of my parentheses need to multiply to 2 and add to 3, and 1 and 2 do that just fine. I need to get the numbers that are going to go in my domain by setting the factors equal to 0. If you stopped here and wrote x equal negative 1 and x equal negative 2 for an answer, I'd probably take off 3 points on a 6-point question, maybe 4 points. To write the domain in interval notation, I take and create a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and the numbers from my algebra in an appropriate order between the infinities. -2 is further left on the number line than -1, so I wrote it first. And then I create round parentheses and intervals. For problem 5, I'm going to get 3 intervals for my domain. One's going to go from -infinity to -2, and these are all round parentheses. And then -2 to -1, and then -1 to infinity. Usually when a domain has more than one interval, you separate the intervals with a U symbol, which means union or. 6 is finding the domain of a square root. To find the domain of a square root, you take the radicand, that's the stuff that's under the radical, set it greater than or equal to 0, do the algebra to isolate the x, and then change the inequality into an interval. The inequality that I get is x is greater than or equal to 6, and as an interval, that's the interval from 6 to infinity. Is any number starting at 6, including 6, bigger than 6, so up to infinity. I get a square bracket there because of the or equal to. For 6, the domain is 6 to infinity. And for 7, this is a polynomial. And polynomials require no algebra to find the domain. If you do any algebra, you're going to make a bad mistake and lose probably 6 out of 6 points if I can't even spell algebra. But anyways, if I graphed this on my calculator, the graph would look something like this. The graph would need to be extended in this direction. So that would go like this. And the start of my domain will be the left edge of the x-axis, which is x equals -infinity. And if I extended this, it would give me the end of my domain would be x equals positive infinity. The domain of any polynomial is just negative to positive infinity without any algebra. If you do algebra, you're going to get the x-intercepts. This graph crosses the x-axis at the point -4, 0 and +4, 0. If you do algebra, you won't get a place where the graph has breaks. You won't get a left or a right edge in a graph, but you'll you'll get something that's nonsense in terms of finding a domain. So you don't need to graph it. Just recognize if I have a polynomial, which for us, if it's not a square root and it's not a fraction in this chapter, and I ask you to find the domain from a function, it's a polynomial. Polynomials require no algebra. The domain is negative to positive infinity, and you don't need to sketch a graph. 8, 9, and 10 have some function notation. 8 wants me to find f minus g and evaluate it at x, which doesn't mean to multiply by x. It just means don't change the x to another letter or a number. To do number 8, I create 2 parentheses with this minus sign between. In the first parentheses, I put the right side of the f function because the f is the function that's mentioned first. In the second parentheses, I put the right side of the g function because it's the function that's mentioned second. And then I do the algebra to get rid of the parentheses. First parentheses, I just drop it. Second parentheses, I attach the negative to the 3x. I change the sign of the -1 to +1. And after I clear the parentheses, I combine like terms. The like terms are 2x minus 3x, which is -x or -1x. And 5 plus 1 is 6. Nine wants me to find g composed with f of x, and this symbol doesn't mean multiply. It means to change the x in the first function mentioned to the right side of the second function that's mentioned. So it wants me to change the x in the g function. The g function is 3x minus 1. The g function is mentioned first, so its x is going to change, and its x is going to change to the right side of the function that's mentioned second, which is 2x plus 5. And when I do that, I'm going to get 6x plus 15 minus 1, and my answer to problem 9 is going to be 6x plus 14. Ten wants me to find f plus g and evaluate it at 2. And what we did when we're asked to plug a number in is first we figured out the function if the problem had an x, so I could tell what x is to change to 2. So I'm going to find an unsimplified version of f plus g of x. To do that, I put a plus sign, and on either side of the plus sign I put parentheses. In the left parentheses I put the right side of the f function because it's the function that's named first. In the right parentheses I put the right side of the g function because it's the function that's named second. I don't really need to simplify that. It's easier to simplify after I plug a 2 in. So I'm going to plug the 2 in, which is required for problem 8. And then I'm just going to simplify this down to a single number. The first parentheses is 4 plus 5. It'll simplify to the number 9. The second parentheses is 6 minus 1. It'll simplify to the number 5. And for an answer, I just need to write the number 14. 11's a big deal because you need it in calculus. Actually, 11 and 12, the next two problems, are important in calculus. And remember, when we did this, we tried to change the numerator to match with what it needs to match with. Specifically, in my numerator, I'm going to have 2 parentheses when I start doing the algebra to find the difference quotient. The parentheses will be separated by a minus sign, and in the right parentheses I'm going to take the given function and put a 2x minus 3 in the right parentheses in the numerator. For the left parentheses, I need to figure out what I can replace f of x plus h with. So I'm going to figure out what f of x plus h is by going to the original function and changing the x to x plus h. F of x plus h, I'm going to replace it with 2x plus 2h minus 3. Because that's how you find f of x plus h. You change the x in the f function to x plus h, and then do the math to simplify. So the difference quotient that I need to calculate for problem 11 is going to have a new numerator, but its denominator is going to stay h. Its numerator is going to have parentheses 2x plus 2h minus 3. That's what I replace f of x plus h with. Then the minus sign from the formula, and then after the minus sign from the formula, 2x minus 3 in place of the f of x. The denominator stays h. Now I'm going to simplify, and in the numerator, the first parentheses wasn't just really necessary. I can just drop it without changing any of the contents in the first parentheses. The minus in front of the second parentheses will, as I'm clearing the parentheses, will make the positive 2x change to negative 2x. It will make the negative 3 change to positive 3. When I'm finding difference quotients, the pieces in the numerator that don't have x's, h's will cancel. The 2x's cancel, the 3's cancel. And I'm left with 2h over h. The h's are going to cancel. And my answer to number 11 should just be 2. Not that you can see that so well. 12, I also always put on a test because you do it right in the beginning of a calculus class. The average rate of change is a slope of a line that connects 2 points. And the way problem 12 is trickily worded, it asks me to find the average rate of change. It gives me a function and it gives me 2 numbers. Those 2 numbers are supposed to be the x coordinates of points. I need to get the y coordinates of each point so I can find the average rate of change. I find the y coordinates of points by plugging the given numbers into the original function. I think it's like 0 and 32. Let me just do this on my calculator. So the top y is going to be 0 cubed plus 6 times 0 squared. Top y is 0. Now second and enter. For the bottom y, change those zeros to 2 and get 32. So my average rate of change is just the slope of the line that connects those 2 points. I'm going to subtract the y's in the numerator, the x's in the denominator to find my slope. And my answer is just the number 16. I could write the word average rate of change next to the number, but if you looked at my answer key, you'll just see the number 16. I don't take the time to write those words. (13) gives me a piecewise function, so I'm going to plan ahead on this piecewise function based on the number I'm given. What am I going to plug in? I'm going to create a number line that has 2 and 5 on it, and I'm going to place each function kind of where it belongs. The first function goes to the left of 2, and it's x plus 5, and I'm going to put a solid circle and a line tracing to the left of 2. This is a representation of x is less than or equal to 2. Solid dot on the 2 means it includes 2, and that's the or equal part, and less than is off to the left. The middle piece goes between 2 and 5, so my middle piece of x squared plus 6 starts at 2, open circle on the 2 because it doesn't have an or equal to, closed circle on the 5. If I'm asked to evaluate the function on 2, I need to go to the function that's connected to the closed circle. If I'm asked to evaluate the function at 5, I need to go to the function that's attached to the closed circle. Last function goes when x is greater than 5. X is greater than 5 represents a round circle on 5 and an arrow that goes off to the right. So I have 3 separate functions, and depending on the number I'm asked to plug in for x, I'm only allowed to plug it into one of the functions. So all I'm going to do is take the number that I'm asked to evaluate and inspect. The first number I'm asked to plug in is 2. I go up to 2, look for the closed circle. I'm going to plug 2 into the function x plus 5 to get my y. The answer to part A for number 13 is just going to be the number 7. I could write g of 2 equals to 7, but 7 is adequate. Part B gives me the number 6. The number 6 would appear here on a number line, so I must be plugging it into the 5x function, because that function handles any number bigger than 5, and 6 is bigger than 5. The answer to part B is just going to be the number 30. Part C wants me to plug in 5, and I'm going to go to the function that's marked with the closed circle at 5, which is the x squared plus 6. The reason I have a closed circle at 5 on the top, the x squared plus 6, is because it has an or equal to. The reason I have an open circle on the 5 for the 5x is because there isn't an or equal to. So I'm going to plug into x squared plus 6 and make this 5 squared plus 6, which is 25 plus 6. And my answer to part C will be 31. A bunch of problems coming up that have no algebra, which means you just got to completely understand what they're asking. Each of the parts of number 14 is calling out a point. 14a and 14b are calling out a point that has the given x. 14a is calling out the point 2, -6, because in function notation, if the number that's given to me in a problem is inside of parentheses, it stands for an x, and I'm asked to give a y for my answer. For an answer to 14a, I just can write the y-coordinate of the point, or I could write the whole problem followed by the y-coordinate of the point. 14b is asked the same way. 14b is looking for a point that has an x of -6, because the number that's presented is in my parentheses. If a number's in a parentheses, it stands for an x. When I go to write an answer, I just want the y-coordinate of that point. If I take the time to write the problem with the answer, fine, but it's not necessary. The next two problems, the numbers that are given are to the right of the equal sign. These are looking for x values that have points with those as a y value. Problem 14 is looking at these 2 points because they have a y equal to 2. And in function notation, if the number that's presented is to the right of the equal sign, it stands for a y. In function notation, if the number that's presented is inside a parentheses, it stands for an x. So these are the points that 14c is calling out, because those are the points that have y equal to 2. Here, my answer is not going to have function notation. It's just going to say x equals, and it's going to be x equals the x value of the points that I just pulled out. Part D gives me a -6 to the right of the equal sign. The point that part D is calling out is this point 2, -6. And the reason it's calling it out is because its y is -6. The reason 14a was calling out that same point is because its x is equal to 2. Oh, this is not a good question. There should be another, I'm missing a point over here. This should have, I should have marked this point right here. I should have marked the point -4, -6 as well, because it's necessary. I'll have to fix that on my graph. And even though it wasn't marked, there is another point that has a y equal to -6. I should have had that marked. I didn't catch it. I should have written these points, and my answer is going to be x equal to -4 and 2. And it doesn't matter at all the order that I write these numbers in. Some more non-algebra problems. Give you a graph and you find where the graph is in the intervals where the graph is increasing and decreasing. Find the maximum point, maximum value, minimum point, minimum value. So to do the increasing and decreasing part, let me wait on those. Let me do the maximum and minimums before I destroy this graph. This point -1, 4 is a local maximum point. It's higher than any point close to it. That point 1, 0 is a local minimum point. It's lower than any point close to it. So the local maximum point, local minimum points are easy. And then the maximum and minimum values are the y-coordinates of those points. So the local maximum value is y equal to 4, and usually we tack on the x. And I got lazy in the videos. I'll get lazy for part F, but this is the non-lazy way, saying which occurs when x equals -1. For the local minimum value, it's y equal to 0, which occurs when x equals to 1. Now let me do the increasing and decreasing, because I'm going to destroy the graph. So to do the increasing and decreasing, I separate the graph into regions. The region before the maximum point, between the maximum and minimum point, and after the minimum point. And in terms of x's, I describe the region. The first region goes from the far left edge of the x-axis up to the local maximum point that has an x-coordinate of -1. For increasing and decreasing, we always use only round parentheses. The middle interval goes from the x-coordinate of the maximum point, which is -1, to the x-coordinate of the minimum point, which is +1. And then the far region goes from the x-coordinate of the minimum point, which is 1, to the x-coordinate at the end of the x-axis, which is infinity. So for each region, I have to decide whether the graph is increasing or decreasing. And in the first region, if I'm tracing on this graph, my marker is going higher as I move from left to right. So this is an example of an increasing interval. So when I go to write my answer to 15a, I'm going to write -infinity to -1 double round bracket as part of the increasing. This middle interval, as I'm tracing, my marker is getting lower. That's an example of a decreasing interval. So when I go to write what my decreasing interval is, it's going to be -1 to 1. And then the third and the last interval, as I'm tracing on it, my marker is getting higher. So this is another increasing interval. It's going to go into my answer to 15a. And that's an interval from 1 to infinity. And usually, when you get multiple intervals, you separate them with a u. So this must be a good stopping point. We've got a few more problems, probably another 10 to 12 minutes, that I'll do in a part 2.